All right, here goes our first attempt at flipping the classroom. This is Mr. Meyer at the plush Way Happy Studios here in Livermore. And we are going to start section 4.7, and we are going to talk about inverse functions. So let's talk about inversing sine, cosine, and tangent and see what happens. So as you know, when you inverse a function, you switch x and y, solve for y, or you reflect it over the y equals x line, whichever one you like to do. And one quick check to do is that you could do a horizontal line test on a function to see if its inverse is a function. So really quickly, let me show you sine, and let's throw a horizontal line in. And if I slide that horizontal line around, notice it's hitting more than once, so sine's inverse is not a function. Same thing happens to our good friend cosine, obviously. And bad news, same thing happens to tangent. They are not functions. But then some clever folks figured out that if we restrict the domain, like looking at this tangent graph, if we only look from negative pi over 2 to pi over 2, we will have a function. It just repeats anyway, so let's just talk about that little range. Same thing with sine. If we only look at sine from negative pi over 2 to pi over 2, it will be a function, the inverse. And cosine's got a little trickier. We're going to have to go from 0 to pi over 2, and 0 to pi, and we will also have an inverse that is a function if we restrict those domains. So the good news, that's what we do. We restrict the domains. So as the domains are restricted for us, that means that we will be able to talk about the inverses and figure out what people are talking about when they give us, who has a sine of root 2 over 2? Who has a sine of, root 3? And you will have to figure out which angles these are. Now the good news is you have to keep yourself focused on the fact that arc sine, what I just erased here, arc sine is stuck in quadrants 1 and 4. So is arc tangent for that matter. And arc cosine lives in quadrants 1 and 2. Because we had to restrict their domains of the original ones of cosine. We had to restrict its domain so that the inverse could actually be a function. Now with that being the case, we should be happy enough to know that we can solve many inversing problems. So there are the graphs, and now we will look at how we solve these inversing problems. So the first thing you might run across is the notation. I can either use cosine to the negative 1 to denote inverses, or I could use the word arc. So as you see in example 1a, I'm using to the negative 1, while over in 1d, I'm using the word arc. Both mean the same thing. Tell me, whichever trig it is, tell me what angle has that answer for that trig function. So using 1a as our first example, I'm asking you, who has a cosine of 0? So hopefully your trick would be that you would look at your hand and you would say, well, cosine of 0 is the top fingers. So cosine of 0 means there'd be no fingers on the top, and that means I would have to fold down my thumb. And if I fold down my thumb, that means we're talking about a 90-degree angle, or pi over 2 in radians. So who has that cosine? That would be our good friend pi over 2. Now remember, we have to restrict ourselves for cosine in the quadrants 1 and 2, and that does fit in there, so we are good. All right, let's talk about arc sine. Arc sine is your bottom fingers. Who has a sine of 0? So again, I look at my fingers. The bottom fingers need to be 0, so that means we're going to fold over our pinky. There's nothing below our pinky. That means that we have a sine of 0. And we found our answer, that 0 degrees, or 0 radians, will be our answer to who has a sine of 0. Again, remembering that arc sine and arc tangent have to live in quadrants 1 and 4. So there's the other notation. In C, I noticed that I might be in a little bit of trouble because on my hand, we always do it over 2 fingers, or over 2. We don't do it over root 2. So let's clean that up a little bit. Multiply top and bottom by root 2. That will give us root 2 over 2. And now I'm ready to figure out whose angle has 2 fingers on the top when I'm looking at sine. I'm sorry, 2 fingers on the bottom. So when I'm looking at sine, if I fold down my middle finger, I will have 2 fingers, which would represent root 2 over 2 like we want. So therefore, we must be talking about a 45-degree angle or pi over 4. And we continue this pattern of just trying to figure out what angle is given to us. Let's do D, arctangent. Arctangent means a tangent of 1. So a tangent of 1 means that the bottom fingers over the top fingers would be 1. Well, there's only one way for that to happen. If I fold down 30 degrees, it's going to be 1 over root 3. Not going to work. If I fold down 60 degrees, not going to work. The only one that will work is that middle finger that will put root 2 over root 2, or also known as 1. We're talking about 45 degrees again. Sweet. So now I just go back and say, hey, you must be talking about pi over 4. Now notice, if that would have been a negative 1, we would have had to move that to quadrant 4 and said it was negative pi over 4. And hopefully that's coming up. Oh, yes, it is in F, G, and H. All right, let's talk about E. E says, who has a cosine of 1/2? Good that the denominator is 2. Means I can use my hand perfectly. Cosine is quadrants 1 and 2. Don't forget, go back to your hand. Cosine is the upper fingers. We only want to see one finger, so therefore we should fold this guy down. And if I do, that means we're talking about pi over 3 or 60 degrees. And now I know that that answer is pi over 3. So far hasn't been too tricky. Now let's see about this tangent. We have an arctangent of negative root 3. So tangent being bottom fingers over top fingers. That means there should be root 3, but be careful, it's negative. Well, to have bottom fingers be 3, you must be folding down your pi over 3 finger again. However, or 60 degrees. However, it's negative this time, meaning that that is the reference angle of whatever quadrant we are living in. So we know the angle is pi over 3. However, now I got to go to tangent, who lives in quadrants 1 and 4. And I can tell you that that reference angle then should be negative pi over 3 because we want to be in quadrant 4. Now arcsine, also quadrants 1 and 4. Who has an arcsine of negative root 3 over 2? Means that I should be looking at sine having root 3 fingers, or I'm sorry, 3 fingers on the bottom. So sine is your bottom fingers. To leave 3 fingers, you'd have to fold down this guy. Hey, you're also talking about pi over 3. But remember, that is our reference angle since it was negative. So negative pi over 3 would also have an arcsine of negative root 3 over 2. And last but not least, arccosine. Arccosine of root 3 over 2, wow, it's negative. That means it's in quadrant 2, not quadrant 1, because everybody's positive in quadrant 1. In quadrant 2, we have negative root 3 over 2. If I go to my hand, cosine is the top fingers. I want to see 3 fingers on the top. Means fold down this guy, your old 30 degrees, or pi over 6. Now, pi over 6 is going to give us an angle in quadrant 2. Because here's where pi over 6 would be, and that's where cosine would be negative. So I just need to figure out what this angle measure is, and that angle measure, well, if this is pi, or 6/6, we'll subtract 1 off. This is 5 pi over 6. And there you have it. Using your hand and figuring out arccosines, arcsines, and arctangents, you can figure out whatever angle we are. Remember to restrict the domain. Remember that sine and tangent are only in quadrants 1 and 4, and cosine is in quadrant 1 and 2. Stay happy.